For decades, space travel has been limited by one major challenge: speed. Our fastest spacecraft today would take over 70,000 years to reach the nearest star. But what if we could cut that time down to just decades, or even years? What if NASA has discovered a near-light-speed engine capable of revolutionizing space travel forever? Reports are circulating that NASA is working on breakthrough propulsion technologies that could one day make interstellar travel possible. Some claim that we might be on the verge of a propulsion revolution unlike anything we've ever seen. But is this real? Could this engine truly exist? And if so, what does it mean for the future of humanity? Traditional space travel relies on chemical propulsion, a technology that has been around for centuries. From the first rockets developed by Robert Goddard in the early 20th century to the Saturn V that took us to the moon, rockets have always used burning fuel to create thrust. While this method is effective, it has a massive limitation: it's too slow for interstellar travel. Even the most advanced spacecraft today, like NASA's Parker Solar Probe, which holds the record for the fastest human-made object at 430,000 miles per hour, is still nowhere near the speed required for interstellar missions. To put that into perspective, light travels at 670 million miles per hour, which means we would need a propulsion system thousands of times more powerful than anything we have today. Over the years, scientists have explored several potential propulsion systems that could make near-light speed travel possible. Ion propulsion is not science fiction, it's already being used in space. Instead of burning fuel, ion engines generate thrust by accelerating charged particles, ions, using electricity. The result is a much more efficient propulsion system than chemical rockets. NASA's Dawn spacecraft, launched in 2007, was powered by ion propulsion and successfully visited two asteroids, Vesta and Ceres. While ion engines don't generate high thrust, they provide continuous acceleration, allowing spacecraft to reach very high speeds over time. However, ion engines are too slow for near-light speed travel. They work great for long-duration missions in space, but they can't generate the kind of acceleration needed for interstellar journeys. Another promising technology is nuclear thermal propulsion, NTP. This method uses a nuclear reactor to heat hydrogen fuel, producing far more thrust than ion propulsion. NASA has been researching NTP since the 1950s, and recent developments suggest that a nuclear rocket could cut the travel time to Mars by half, from 9 months to just 3 to 4 months. While NTP is a major improvement over conventional propulsion, it still isn't fast enough for interstellar travel. To get even closer to light speed, scientists are now exploring even more radical propulsion concepts. One of the most powerful propulsion ideas is antimatter propulsion. In theory, when matter and antimatter collide, they annihilate each other, releasing an enormous amount of energy, far more than nuclear reactions. If we could harness this energy, it could allow a spacecraft to reach near-light speed velocities. The problem is that producing and storing antimatter is extremely difficult and expensive. Currently, scientists at CERN can only create nanograms of antimatter, and we would need tons of it for a functioning propulsion system. So, while antimatter propulsion is theoretically possible, it's not a viable option yet. This is where things get even more futuristic. Some researchers believe that quantum inertia, a concept proposed by physicist Mike McCulloch, could allow for propulsion without traditional fuel. Quantum inertia suggests that a spacecraft could generate thrust by interacting with the quantum vacuum, the lowest possible energy state in space. If this concept is proven, it could provide a form of reactionless propulsion, allowing spacecraft to accelerate without ejecting mass. NASA has partially explored similar ideas in the past, including the M drive, which allegedly produced small amounts of thrust without any fuel. However, the M drive remains controversial, and many scientists believe its effects were due to experimental errors rather than a real propulsion breakthrough. Still, if quantum propulsion ever becomes reality, it could be the key to unlocking near-light speed travel. NASA and other space agencies are actively researching advanced propulsion systems, but so far, no publicly confirmed near-light speed engine exists. However, there are classified projects that could be working on futuristic propulsion technology. Elon Musk's SpaceX is also at the forefront of space innovation, developing the Starship rocket, which aims to take humans to Mars and beyond. While Starship still relies on chemical propulsion, Musk has hinted at nuclear propulsion and even more exotic concepts in the future. Meanwhile, DARPA, the U.S. Defense Advanced Research Projects Agency, is working on nuclear spacecraft propulsion, and NASA's Glenn Research Center is studying breakthrough propulsion physics. Could one of these programs lead to the first near-light-speed engine? Possibly. But we are still far from making it a reality. If we could develop a propulsion system capable of near-light speeds, it would completely redefine space exploration. A trip to Mars could take days instead of months. Interstellar probes could reach the closest stars in decades, not millennia. Manned missions to deep space would become a reality. It could possibly even break the light-speed barrier one day. While it may sound like science fiction, remember that just a century ago, people thought landing on the moon was impossible. Now, we're planning missions to Mars and beyond. The search for a near-light-speed engine is ongoing, and while we don't have one yet, the technologies being developed today are setting the stage for the future of space travel. The question isn't if we will travel at near-light speed, but when.